I was working on the FM alignment for this Philco, and I did something really stupid and clumsy. You see, I was using this little transmitter to check my work for FM. And I've had this transmitter for a couple of years, and it's given me pretty good service. It's not the strongest, most powerful transmitter in the world, but it does okay. I mean, you know, it does a good job of doing what I need it to do, and that's just transmit a signal within the room so that I can check the performance of an FM receiver as I'm aligning it. Well, I turned to grab something, and I hit this thing and snapped the antenna clean off. Now, I have to say, it wasn't actually built all that well, so it shouldn't have snapped off and maybe should have bent, but I mean, it broke off clean. So, I'm going to have to repair this bugger, but I don't have time to do that right now, and the truth is, I saw it as an opportunity to get myself a better transmitter. I went out to my favorite shopping center, Amazon, and I found this little guy, and I'm pretty tickled with it. Check it out. This thing is awesome. It transmits across the entire FM band. Now, it does have a fan. It's fan cooled, and it uses a magnetic mount antenna, which I've, just stuck to the side of my rack here. That is it's telescopic, so it's completely adjustable as far as length goes, which is important for setting up a transmitter. And when you attach it to a large piece of metal like this rack, it actually has a better ground plane to work with and does a better job of transmitting. Completely adjustable in terms of frequency, 10 kilohertz at a time, just like you might expect. It has a microphone input and, of course, an auxiliary input, and it's an all-metal housing. It has a computer-style fan in it. The fan's a bit noisy, as you can tell, as you can hear. It's a little on the noisy side, but I can live with that. That's not a big deal. And what's really cool about it, this thing is adjustable you can either transmit at 5 watts output or 15 watts output power. And I have taken a portable FM radio and I walked down the street and around the corner and down to the end of that street, and I was still receiving a nice, clear signal. And that's about a half a mile away. I'm figuring this thing will transmit 2 or 3 miles away. I'm pretty impressed. And it takes very little effort to set up. You come in, you hook everything up, you adjust the length of the antenna. It gives you a chart that shows you all the functions, and it shows you a graph of just how long the antenna should be given the frequency at which you want to transmit. And I'll give it a shot at the name here. It looks like Niorfinio? Who knows? Whatever it is, it's pretty good. You'll see it on Amazon. There's only one like it. And they had plenty. I think they had 16 in stock when I ordered, and I got it prime in 2 days. So you'll find this thing works great. Forgive the recording in this next one too. The battery died again in the recorder. I'm going to be starting to use a new recorder here shortly, so I won't have this problem coming up soon. Well, guys, I have to tell you, I had one heck of a hard time getting the FM aligned on this radio, and I know I did everything right. I have this Sam's PhotoFact here. You can see I printed up large because I'm blind as a stinking bat. And I followed every instruction to the T. I checked and double checked the location of every adjustment point on this thing. I labeled everything. I went through step by step by step. They're all labeled clearly here. By the way, this is just a heads up. If you use the Sam's instructions, you have to use the Sam's diagrams, because the way Sam's works is they basically do a reverse engineering deal. They take something down, or at least they study it, and they number everything with their own numbering scheme. So if I compare a Sam's schematic to the original schematic produced by Philco, there are some benefits to using the Philco one. Like this one breaks it up into sections, which is kind of handy in some ways, a pain in the butt in other ways. But all the numbers on the Philco schemo are completely different than the numbers on the Sam's schemo. That's just something to keep in mind. If you have both, you make sure that if you're using the parts list and the call-out diagram from Sam's, you must use a Sam's schematic if you want to understand the numbers that they've applied on the call-out and the parts list. But anyway, I was using the Sam's, And I followed every stinking step on this guy. I mean, every step. And I did it like 5 times. I made my own sort of loop antenna, and I did this a long time ago with a priority mailbox and about 5 loops of solid core wire, real small gauge wire, leaving some leads coming off of each side that I then hook up to the signal generator directly. So I transmit into this little loop here, and it radiates out to this loop antenna here, and that is the loose coupling that they talk about in a lot of alignment instructions. So they say a few loops of wire. That's what this is, a few loops of wire. And then I made the IF and the oscillator and all those adjustments. I fine-tuned every one of them after I did this, and I got much better results. That's on the AM side. So the AM's working fine. Took me a few passes to get that right, because these Sam's instructions, while they got me in the neighborhood, really didn't give me the best results in terms of alignment for final alignment. I'm not sure why that is. I've got to give that some thought. So once I got the AM aligned, then I followed the Sam's instructions again for the FM alignment. Using a 9.1 megahertz IF signal, I basically tuned the FM portion of the IF transformers and got that all set up. And then you start working on the discriminator and the limiter, and the whole point of that is they talk about maximum deflection. It took me a long time, several passes, to sort out that what they meant by that. They're talking about using a vacuum tube voltmeter. And of course I use my Fluke, because my Fluke gives me just as good a results, and I can see there's a little bar graph on the bottom and it tells me which direction it's going. So this serves the same purpose as a vacuum tube voltmeter for me. You can argue with me all day long if you want to. I've got a nice Hewlett-Packard VTVM. I almost never use it because it's such a pain in the keister to set up. So I use my Fluke, and I use that 9.1 megahertz, and I did the adjustments on these 3 IF transformers, and I mean, I was getting awesome signal pass through. Awesome. It was sounding great in the speaker. I was getting the results I expected. Then you go and you mess with, like I said, you mess with the limiter and the discriminator. You look, when you look for those deflections that I mentioned a minute ago, what you're really trying to do is you're nulling it. You're not peaking it, you're nulling it. It took me a few passes to learn that, because there's a peak on this side and a peak on this side and a null in between. But that number is always the biggest. That represents maximum deflection. So it might be hard to see, but if you look at these instructions where it talks about making the final adjustments on the FM, it talks about tuning for maximum deflection, as I mentioned. That doesn't always mean loudest sound, okay? Just make sure you're watching your VTVM or your digital multimeter for that. You're tuning the FM RF coil, the FM oscillator, and the FM antenna coil. And what those are actually, and I can't show you because I've got the radio plugged in right now, I don't want to be tipping it. They're really coils about a centimeter in diameter and about 6 or 7 actual loops in the coil of sort of heavy gauge copper wire. It might be hollow, it might be solid. And what they have you do to make adjustments is compress those coils or stretch them out, kind of like doing a spring. You squeeze the spring down or you stretch the spring out, very, very, very small amounts, to get resonance in those coils. Here's the deal. You need a tool that's something like this, that's got a brass slug on one end and what they call a sintered iron, sort of that black iron, powdered iron slug on the other end, that you actually insert into the coil, and you look for the direction of the deflection of that VTVM, and that tells you whether to stretch it apart or squeeze it together. Here's the problem. I don't have one of those tools. I'd like to find one. I've seen FM alignments call for it a couple times. I've always gotten good enough FM performance without it that I haven't needed to do it, but the truth is this radio I've struggled with, and I got it, but it took a lot of messing around to get it, and sometimes I would compress those or stretch those a tiny bit and screw it up and have to find my way back, and that's hard to do, guys. So I'm going to look for one of those, and if you're doing FM alignments, you need to get one too, because those coils are just as important as making the RF trimmer adjustments in AMR. So it's real hard to get it right if those aren't right. But I will tell you, I did finally get it. Here we go. Let me turn this up for a minute. This is playing. This radio is playing from that FM transmitter right now. So I'm playing a little bit of music from my phone to that transmitter. Of course, as always, my favorite artist, Glenn Hansard. And it's working out real well. That speaker is sounding pretty darn good. And the FM is actually performing well. There's a little bit of the FM hiss that comes with FM, especially in the older radios, and you get some drift. This is pre-automatic frequency control. There is, of course, an automatic volume control in there, or automatic gain control, they tended to call it in the FM world. But it is pre-automatic frequency control, so this thing will drift a little bit. It's working pretty darn well, and I've got that transmitter, like I said, set at the low power setting at 5 watts. And I'm doing pretty darn well. So let me show you a little bit of AM. Let me take it off of FM here. This is my special one-off knob for this radio. Okay, now we're on AM. Let me turn off these noisy lights. We'll darken the room a little bit.
Thought you would think it was foolish. But with cooler, I just am a little hesitant.
So 1370 KSOP, Salt Lake Classic Country, of course. When I turn that loop, I get 1430 pretty well, but when the loop's leaned against the wall, for some reason, it just deadens it, man. It's very directional. See, I can pick up other FM stations down here. I have to tell you, I've been struggling because the signal strength must be really weak down here, and plus, this radio uses an in-cabinet antenna, and that antenna went with the cabinet when the owner took the cabinet, and I'm not sure how it's set up. Well, I didn't realize it at the time, but I was full of malarkey here. The truth is it wasn't receiving FM because it wasn't aligned right, and I wasn't getting that great of AM reception either, and the more I fiddled with this, the more dissatisfied I became with it. So I didn't really show a whole lot more messing with it here, but what wound up happening is I decided that I better do some things like testing tubes and maybe redoing the alignment once or twice with a better signal generator. So I still have a bit of work to do on this. At the time I was recording this, I thought I was nearly done. I was feeling pretty good. But the more I listened to it, the more I played with it, the more unhappy I became with it. So let's get on to the next steps, the things that I eventually came to the conclusion I needed to do, like the signal generator and the tube testing. A lot of people are under the impression that tubes are the things that fail for people. When their radio's not working, the first thing they think about are tubes. And truth is, tubes don't fail all that often. They're in a vacuum, for crying out loud. And unless they're mechanically harmed, dropped or banged around or whatever, there's really not much to go wrong with them except to have a gradual decrease in emissions as the coating on the cathode, kind of depletes and that kind of thing. So, but I'm really stalled on this FM, on this Philco. I can't figure out what the heck. I've done the alignment like 4 times. The AM's working great, everything else is working great, but the FM still stinks. So let's go through these tubes and let's just make sure that the tubes are all okay. I'm not looking for perfect tubes because I have seen lots of radios that work with tubes that are not perfect, but I'm looking for decent. So first we're going to start with the 6AG5, and we'll stick that in there. We need, oops, I shouldn't stick that in first. What we need, I'm on my old Hickok 600A. Okay, I just got this in the mail a couple weeks ago. I bought it on eBay, and it seems to be working great. 6AG5, 6.3 on the filament. If those of you that know Hickok's scheme of doing things, you'll recognize this. So it says JR3562. So these are all set correctly with a 0 at the suppressor. And let's see, the English, it says I should either pick 85, or if I want to read in micromodes, go to this red dot here near the 85. So because that's the scale for the 1000 to 6000. By the way, the mutual conductance of this should be about 4000 micromoles if it's a really strong tube. So it's all set up. Let's go ahead and stick the tube in the socket. Okay. Now I like to let the tube warm up and then I check the line, do a line adjust, because that's affected by the tube heater current. So it should be warm enough. Let's take a look. We can adjust it just a little bit. Here we go, sitting right there in the center. It's supposed to line up with this where it says line test, that black line. Now it says to go ahead and push P4 if I want to read mutual conductance. So what am I getting? I'm getting about 32, 34, 35, about 3500 out of 4000. I will call that a pretty good tube. I need to mention that this 6AG5 I had replaced way back when I did the initial bench test of this radio. And I knew that because I went back and looked at my notes in my early video, and I had a dead one, a completely dead one. I plucked it out, and I went and pulled this one out of my stock and put it in there. It's a good thing I looked at my video. I was looking for something else. Now I have a 6BA6, so let me look for that. Bias is 0. It was 0 on the last one too, I just forgot to mention it. 79 on the English. Okay, tube is warmed up. JR 35672. Okay. Line adjust is right. Let's hit P4. I'm getting about I'm getting real low. I'm at about 1,000. This thing is a bad tube, I think. Let's go here to this and see. Yeah, that's a bad tube. So what if we're on the 1,000 to 6,000? Let's see what happens. Yeah. Okay. So I've got 1,000 on this 6BA6. I got 1,000 out of 2,700, so that's a bad tube. Alright, I don't have any more compact tubes. Let's do a Lochtel tube, 7F8. Kenneth Scharf told me something interesting in a comment, that Lochtel tubes really aren't 7-volt tubes like a lot of people think, including myself. That was just a number that was given to them, I think by Philco. I think that was a Philco proprietary thing, Lochtels. That number was given to them by the manufacturer to make them look different. Alright, 7F8. 6.3, just like an octal. Okay, let's go ahead and stick this in there and let it warm up. Should be there now. Just do a line adjust. That's right. Okay. It says to push P4. P4 it is, and I'm showing bad there too. Okay, so it should have 4,000 micromoles. And that's for one of the triodes, okay? So that should be 4,000 micromoles. 1304-0, 1304-0. Filament's lit, or wouldn't be doing anything. Alright, bias of 785. It should show green. Okay, that's what the English is for. It's supposed to show green. Alright, so let me go to the number that it says to set it at. Or let me go to the red dot. So on a Hickok, you can either select the English number, and that'll allow you to read the red or the green. Okay, that kind of made this one like an emissions tester. Or you can set it to the red dot that is for the scale you want to read. When you set it to that red dot, well, then you can read the micromoles right off the meter in numbers. So this is supposed to be 4,000, so I'm going to set it to the red dot. That's from the 0 to 6,000. Okay, everything else stays the same. And what am I getting? Holy crap. I am getting about, oh, not even quite 1200 micromhos. So this is a nearly dead tube. That's interesting. I did not get that. I did not get that. Let me look for shorts. Nope, I should have done that first. Oh well. The other diode, triode, number 1. Click the button. Yeah, there we go. Almost green. Almost green, guys. Alright, let me read the number here. So in that case, I'm sitting at about 2450, okay, out of 4,000. Still not good. Both triodes on this tube are bad. Both of these will definitely affect the FM. But the 6BA6 is the first IF, and the 7F8 is the first detector. Alright guys, I apologize. My battery died partway through this thing, so I'll tell you about what I found in just a minute. But I gotta tell you, man, if you're looking for a little camcorder, you know, one of this style right here, I wouldn't buy one of these. This thing just doesn't seem to it has terrible battery life. I was recording, I had a freshly charged battery, and it's not like I've used this battery to death. I was recording for about 48 minutes, and let me show you, I went dead, and it doesn't tell you when you're about to go dead. It doesn't do anything. There's the machine right there. Alright, I wouldn't buy one of these again to save my life. HDR CX405. All the reviews say these things are great, but there's crap for battery life, man. My phone can go for over 2 hours, and this thing here couldn't go 48 minutes. So, very disappointed. Alright guys, here's what I found. Let's take a look at my chart here. So I did test all the tubes. Unfortunately, my stupid camera died. It looks like it died right around the 7R7 tube. So the 7X7 tested good, tested actually quite good. The 7AF7 tested quite good. The 6V6s tested pretty decent. Where I am bad, you did see, okay? You did see that I have 2 bad tubes. I have the 6BA6 is a bad tube. That tube there is showing 1,000 micromhos out of 2,700, definitely bad. And both of the triodes on the 7F8 are bad. I've got 2,450 out of 4,000 and 1,200 out of 4,000. Those are bad. If I had one kicking around, and I think I probably do, I might try another 7R7 because I'm seeing 2,250 out of 3,000 on the pentode. But I think that's probably okay. I don't think I need to worry too much about that. I've seen tubes worse than that doing just fine. 7X7, look at that, 850 out of 900 were good. The 7AF7, both trials, 2,200 out of 2,600 and 2,025 out of 2,600. We should be okay with those. I mean, they're not great, they're not perfect, but they should work pretty well. 6V6s again, 3,800 out of 4,100, 3,500 out of 4,100 were okay. Here's something. Both of these tubes that are bad have to do with FM. They're both part of the FM. So that before I mess around with any more alignment or anything like that, I need to get these tubes replaced, and then I'll deal with the rest of it. Alright, so that's the status on this. I tested all of these on this Hickok 600A. I have not restored this machine, but the machine appears to be working well. I got numbers I expected out of all of these. The 6V6s, of course, I've tested those before on other testers, and it's looking pretty good. So I see no issues here. I think my tester is doing fine. This was an eBay purchase and one that went well. This guy lives in southern Utah, so I got it fairly quickly, and I think that it'll be a tester I use from now on. I also bought a 533 from Philco, and I'm going to restore that one. I'll mess with that one too. Okay guys, that'll wrap up the tube testing part of this. We'll get back to the chassis once I find those tubes and get them replaced. Okie dokie, guys. I have dug out a tube. This is a Joint Army-Navy tube. You see those, sometimes it'll say JAN on the box. And this is the 6BA6. Let's take a look. I got the tube tester all set up, so I don't waste time on the video for that. Let's see where we are micromo-wise. Alright. Holy crap, look at that. And just under 3,000. Alright, so yeah, I'm on the 3,000 scale, just under 3,000. I'm supposed to have 2,700, so this is a very strong tube. And of course, it's new old stock, so I expect that. Okay, so the 6BA6 we got taken care of. Okay, let's set this up for the 7F8. Now, I've dug this out. This is a new old stock Philco tube. I don't know who made these for Philco. But let's take a look. So I'm not sure how this structure is. It's a really simple tube. It's small, but the two triodes are probably right here. You see the two filaments going in the end. The mutual conductance is supposed to be 4,000. So that would put it on the 6,000 micromole scale. Now we'll push P4. And we're getting about 3,600. Okay, not bad. So the other triode for the 7F8 is 1304. So 1304. Okay, 13040. 7 on the bias. Let's set this up on the 6,000 micromole scale. Yeah, right about where it was before. So when I hold it down for a second, it gradually creeps up a little bit, which is interesting. So, but we're right at about 3,800, so I think we're good. This is a good tube. No need to worry. Again, beats the snot out of the 1,200 that the Triode 2 was on this before. So we have ourselves a good pair of tubes. Like I said, it's a new old stock tube. I usually don't like to give these cartons away to customers because they don't care about them, and I do, because I'll put other tubes in there, but I know this one's new old stock. I mean, heck, look at that. That's never been in a socket before. So that's a thing of beauty, man. That's a beautiful tube. Alright, let me get that in the radio. Part of the problem is that I have been using this old ICO 324 for a long time to do AM and FM alignments. FM alignments on the old machines, right? The ones where you could use an AM function generator to do the job. The trouble is, this at the frequencies we're talking about, because I have to get up to 105 megahertz in order to align with that thing. At 105 megahertz it works, but it's using harmonics to do it, and it's really not as stable as I would like. The signal is not as good as I would like, and I really struggle to get a nice solid signal at the frequency I was looking for. I feed it into the input of this box, and then the outputs, the two outputs, one of them go to the frequency counter. The other output goes off to these leads here that I use to connect to the chassis. Okay, and these are shielded right up to the point where the leads come out of this little block right here. I've been using the 324. It works great for AM, and I'll continue to use it for AM because this unit here does not work for AM at the frequencies that we do for broadcast. But what it does do is work for FM frequencies that are broadcast, okay? So this function generator is a Model 202H. It's a Hewlett-Packard. This thing is a beast. It's not quite as heavy as it looks, but it is heavy. Let me turn it on. This thing is a pretty slick machine. Like I said, it's a 202H Hewlett-Packard. It operates in two bands, 54 to 108 and 108 to 216 megahertz, okay? So 54 megahertz puts it way outside of the broadcast AM range, but certainly 54 to 108 puts it squarely in the FM broadcast range. So that's really cool because this thing is modulated on both FM and AM. Okay, let's go ahead and set this so we can see the frequency coming off the generator. I hope you can see that. There we go. One frequency I have to utilize when I'm doing this is 92 megahertz. So let's see if we can't bump up to 92 megahertz. There we go. It's got a vernier, so that's what's really sweet about this, is I can fine tune this until I get there. Watch that thing. All right, that's pretty close. 92 megahertz. So there you go. There's right around 92 megahertz. It may be out of calibration a bit, but I don't care. I've got a frequency counter. That's all I need. So I'll do an alignment. I'll do it off camera because it's really dull stuff. You're listening to a tone for 2 hours while I tweak on this and tweak on that. It'd be pretty boring to you, but I'll probably film most of it. All right, guys, I'm going to get to work now. Like I said, alignments are pretty boring to watch. I am going to do the highlights in the next part and show you some of the details, like how you take the measurement for setting where the dial needle goes, like I'm doing here in this little scene. I'll show you that stuff, and hopefully you'll get enough out of that and with the alignment instructions that it might be useful to you if you're doing one of these sets. In any event, that's all I have time for today, and so I'm going to wrap it up. From your Western Outpost in Salt Lake City, this is Michael. That's all for now.